So the question we're going to ask next is, can we detect failure early? And the answer is yes, we can. And how can we? We can use forward checking and our consistency, two improvements that we can do to have a better uh, massive performance gains in our algorithms. Okay? So let's see how it works. Okay? So the idea is, Janab, the first we're going to talk about forward checking, and the idea about forward checking is you will do constraint propagation. तो होगा ये जनाब के if you have two variables. So let me develop an intuition before I talk to you about forward checking. So let's suppose जनाब के you have two variables x and y, and x की जो allowed values हैं वो हैं 1 2 3 4 5, let's suppose, and then the y values are um, let's say 1 4 9 16 25 36. Okay, the constraints are y is equal to x square. This is the constraint. Okay, you have to pick a value for x and y such that this constraint holds. It's very simple. And आपका y जो है x का square होना है. So if we choose x is equal to 1, then the only value allowed for y is 1. All other values are not compatible with the value x choice of x is equal to 1. And then what we do, we will remove all these values 4 9 16 25 36 in the domain of y, so that y will remain 1. So look at this way for the map plane problem. For example, like you have two neighbors a and b, and a and b are in constraint with each other, and if a has the values red, green and blue available to it, and b also has the values red, green and blue. So what you will doing, as soon as you assign A as R, right, then you will remove B R from B, because A and B cannot have the same value. So B will remain G and B, and you will select either G or B, and then this thing will help you have a better understanding of the word. Okay, so this is the hopefully that you will have a better understanding of this thing. Okay. So this is what checking is. So again, what you keep track of remaining legal values of the variable that you haven't assigned yet. और आप तब टर्मिनेट करते हैं जब किसी वेरिएबल का उसकी वैल्यू नहीं बचती असाइन होने की. दैट वुड मीन कि फेलियर अगर हो चुका है, देन you do not have any choice to assign any value to any other variable. That's when you have to backtrack and choose another value from the previous variable. Okay, so what happens when after assigning a value x to a variable x, capital X, and you have to see जनाब कि क्या वेरिएबल x जो है वो किसी दूसरे वेरिएबल के साथ एसोसिएटेड है या नहीं, इनकंस्ट्रेंट है या नहीं. लेट्स सपोज के यू वर इनकंस्ट्रेंट विद द वेरिएबल y. सो आप क्या करेंगे जनाब कि अगर x को आपने x असाइन किया स्मॉल x, देन उसका इम्पैक्ट आप y की डोमेन पे अप्लाई कर देंगे, एंड देन मे बी इट वुड इम्प्लाई कि जनाब y से उस वाली वैल्यू x को हटा दें, एंड दिस कुड बी one way of improving your search. ठीक है, so let's take an example, and I'm going to show you the impact of forward checking on the code as well. ठीक है. So let's have, we have this map coloring problem 1 2 3 4 5, and the colors assigned are RGB, red, green and blue. So we start with uh, every domain has these values available to them. So this 1 2 3 4 5 have all RGB. If you choose R1 to be red, then which variables are in constraint bits? So it's 2 3 4 and 5, and you should drop 2 red from 2 3 4 and 5. Okay, so then you select 2 as green, and 2 is in constraint with 3, so you will drop green from 3. Then you will select 3 as blue, and then you would have blue constraint with blue, so you will stop blue from it, and then similarly you will select green and then in green, and that will help you in finding a solution than much quicker than simple vanilla backtracking. And again, another example, the constraint graph for the front from graph for the map problem that we have seen. So again, the problem that we have seen is we try red, and then the northern territory and south Australia will do red. If you choose green for Queensland, then you will see janab green will disappear, and so on and so forth. So as soon as you will find janab के कहीं पे domain empty हो गई है, so you will backtrack. ठीक है, but you can see janab के डोमेन यहाँ पे हमें पता चल चुका था फेलियर आ चुका, बिकॉज टू नेबरिंग वेरिएबल्स हैव द ओनली वन वैल्यू रिमेनिंग। तो किसी या तो एंटी को आप ब्लू देंगे या एस ए को ब्लू देंगे, दोनों का ब्लू नहीं दे सकते। मगर फॉरवर्ड चेकिंग विल नॉट स्टॉप हियर, फॉरवर्ड चेकिंग विल स्टॉप व्हेन एनी डोमेन विल बिकम एम्प्टी। याद रखिएगा इस चीज को, तो डोमेन जब तक एम्प्टी नहीं है जब तक फॉरवर्ड चेकिंग जो है वो स्टॉप नहीं होगा। क्या भरा? So let me show you this thing in some different examples as well. Let's see the impact on efficiency. So remember, okay, forward checking is an improvement that runs inside backtracking. So it is not something that that will run outside backtracking. So it is still running inside backtracking. So, okay. So as we saw earlier, the NAPCA 20 queen problem was too difficult to handle for the vanilla backtracking, and it takes quite a lot of time to find out the answer. But if we switch to a forward checking algorithm, so if I allow forward checking to take place, so we are there is some domain correction, constraint propagation that's going on, then you will see janab ke it has an immediate impact. The solution had been found in less than 1/10 of a second. So 1/7 of a second the solution has been found. Okay. So what I want to do is to uh, take so again, if I turn the variable ordering as false, so we are not performing any variable ordering. So let us see the impact of variable ordering on backtracking search. So sorry, forward checking search. So again, if I do less than 10 variables, you can see the solution has been found. But if I turn this thing on for a 10 problem for 0.02 seconds, it is even faster. So if I change to 20, so 20 is getting solved by forward checking with utmost ease. So again, with variable ordering turned off, that is taking a lot more time. And again, it will solve before vanilla backtrack, but it's taking a lot more time. I'm terminating it, so I'm just turning on the variable ordering, and you can see janab ke why this matters so much. And you can see janab the time is almost immediate. So if I want to find a solution of 50 queen problem, you can see janab the solution will be found in very quick time. Okay. So what I want to do is to compare the performance of backtracking search with forward checking and normal backtracking search in your. So here you can see on the left hand side, it is the performance of backtracking search with out forward checking on a 5 pin problem, and the performance of backtracking search with forward checking. You can see आपके वन के लिए वन क्लिक किया, पे उसने टू को वन ट्राई किया नहीं काम किया, टू ट्राई किया नहीं काम किया, थ्री ट्राई किया, फिर उसने आगे बढ़ा। और जैसे ही उसने क्वीन के लिए वन असाइन किया ऑन द राइट हैंड साइड विद द फॉरवर्ड चेकिंग, तो उसने देखा जनाब वन और टू दोनों काम के नहीं है। उसने वन को बैठा दिया, टू को बैठा दिया, फिर डायरेक्टली थ्री अप्लाई किया। फिर थ्री में उसने देखा जनाब के टू वन टू थ्री फोर तीनों काम के नहीं, क्वीन थ्री के लिए, क्वीन थ्री के लिए फाइव बैठा दिया। फिर क्वीन फोर के लिए उसने देखा जनाब कौन से काम के थे, उनको ट्राई किया, क्वीन फोर में टू काम किया और फिर क्वीन फाइव में फोर काम स्टॉप किया, और उसने बगैर बैक ट्रैकिंग के प्रॉब्लम सॉल्व कर दी। यू कैन सी जनाब लो अमाउंट ऑफ बैक ट्रैकिंग वाज यूज्ड टू सॉल्व दिस प्रॉब्लम। सो वी सॉ कि जनाब किस तरीके से बैक ट्रैकिंग सर्च जो है वो इम्पैक्ट करेगी आपके आपके ये कंस्ट्रेंट प्रोपगेशन जो है वो इम्पैक्ट करती है आपकी परफॉर्मेंस को, आपकी बैक ट्रैकिंग सर्च की परफॉर्मेंस को। दिस इज वेरी यूजफुल, और अगर आप इसको अप्लाई करते हैं प्रॉपरली देन यू विल फाइंड जनाब दिस इज समथिंग दैट इज वेरी। तो अगेन फॉरवर्ड चेकिंग बेसिकली करता क्या है जनाब कि जो अनअसाइंड वेरिएबल से इन्फॉर्मेशन को प्रोपोगेट करता है टू अनअसाइंड वेरिएबल। ठीक है। Forward checking, it improves your backtracking search that it does not look very far in the future. For example, इस context में Northern Territory and South Australia have only one option remaining, and both cannot be applied to blue cannot be applied to both of them. So this is the failure. The failure has occurred, but unfortunately, forward checking will not detect this thing, and the reason is because कोई डोमेन एम्प्टी नहीं हुई है। तो याद रखिए जनाब कि फॉरवर्ड चेकिंग सिर्फ तब डिटेक्ट करता है फीचर को जब कोई डोमेन एम्प्टी आती है, उससे पहले वो डिटेक्ट नहीं करता उसको। So to detect this kind of consistency, so we are going to use some other things as well. One is called the different kind of consistency. The first is called node consistency, in which is part of checking the constraints on a single variable. Our consistency, just going to discuss next, is checks the consistency on every arc. And what does that mean? Okay, for every allowed value of x, so if you are checking the arc between x and y, then for every allowed value of x, there should be consistent values for in y as well. So let me give an example. So let's suppose in our case we take the x square problem. So we have this 1, 2, 3, 4, and then y we have these values. It's 1, 4, 9, 16, and 25. Okay. So if the constraint is y is equal to x square, this is the constraint. Then you can see जनाब कि अगर मैं x में अगर मैं इस constraint वाले को there's two direction x to y is 1, and then we have to check in y to x as well. So let's see x and y. So for this arc to be consistent between x and y, for every value of x there should be some allowed value in y. तो x1 के लिए y के पास 1 है, x2 के लिए y के पास 4 है, x3 के लिए y के पास 9 है, x4 के लिए y के पास 16, and so on and so forth. So this is consistent. Now look in the reverse direction, y to x. तो y1 के लिए x के पास 1 है, y4 के लिए x के पास 2 है, y9 के लिए x के पास 3 है, y16 के लिए x के पास 4 है, मगर y25 के लिए x के पास कुछ भी नहीं है. This is not consistent. To make it consistent, what we're going to do, we're going to delete from the tail. So we remove the value from the tail. This is the tail of the arrow, and this is the head. So we're going to remove the value from the tail, and if you remove 25, then it will become consistent. So our consistency tells कि basically कि दो वेरिएबल्स जो हैं के दरमियान वैल्यूज जो हैं वो कंसिस्टेंट होनी चाहिए. तो अगर मैं किसी एक वैल्यू असाइन करूंगा तो उससे को वैल्यू जो है उसके पास कोई ना कोई अवेलेबल होनी चाहिए. दिस इज समथिंग दैट इज मच मोर पावरफुल दैट फॉरवर्ड चेकिंग, हाउएवर मच मोर कंप्यूटेशनली एक्सपेंसिव एज वेल. Path consistency takes it to a next level where it takes about three or more than two variables, which is not used often. So we will stick to our consistency in this lecture. So इसका मतलब है ना कि again याद रखिएगा ना कि you can convert any n-ary constraints to binary constraints. So again normally जो CSP के जो solve करने के लिए हम लोग इस्तेमाल करते हैं वो convert कर देते हैं अपने जितने भी n-ary constraints होते हैं उनको CSP binary constraints के अंदर. So how does arc consistency work? So again, the idea is the simplest form of propagation which makes every arc consistent. So again, you can see okay, South Australia, New South Wales are in constraint. For South Australia, New South Wales is consistent because for South Australia to be blue, New South Wales के बाद red color बच जाएगा. बट रिवर्स डायरेक्शन सही नहीं है बिकॉज न्यू साउथ वेल्स में अगर रेड है तो साउथ ऑस्ट्रेलिया ब्लू है, मगर न्यू साउथ वेल्स में अगर मैं ब्लू डाल दूंगा तो यहाँ पे साउथ ऑस्ट्रेलिया का कुछ भी नहीं बचेगा. तो द लॉजिक सेज कि रिमूव दिस वेरिएबल, this value from the variable list, and this makes it consistent. You can see जनाब के रेड के लिए रेड अवेलेबल है तो रेड नहीं होना चाहिए. अगर रेड रखेंगे तो न्यू साउथ वेल्स कुछ नहीं बचेगा. ग्रीन रखेंगे तो रेड बच जाएगा, ब्लू रखेंगे तो रेड बच जाएगा. Similarly जनाब and so on so forth. You can apply this thing to many other algorithms. Arc consistency is a pre-processing step, and it's applied before we start backtracking search, but sometimes people do run them in backtracking search as well. So the idea is janab ke you take a look at every arc, and you revise that arc अगर उसमें कोई चीज़ inconsistent आ रही है, ठीक है, तो ये remove the neighbors में से वाली values को आप हटा देते हैं अगर कोई चीज़ जो है वो inconsistent आ रही होती है उस हवाले से, ठीक है. So it is not that bad. So the complexity is n squared dq, where n is the number of variables and d is the domain size. So this is not bad, but you can see जनाब के फवायद बहुत ज़्यादा हैं. So you can sometimes you get to solve the whole problem without ever running backtracking. So just by running R consistency. Okay. So this is how backtracking search in works. So again, all the things are the same, but this is something that we have added, and these inferences are basically either forward checking or arc consistency or both of them. So you can use the forward checking or arc consistency or both of them. Arc consistency is basically a higher form of with forward checking. So if something arc consistent, then forward checking will never find an error in it, by the way. So this is an algorithm. So the procedure AC3. So let's see how it works. So again, we have this constraint graph 1, 2, 3, 4, 5, 6, and the constraint is telling okay, it is not the arts and they should not have the same value. Okay. So this is the set of constraints that we have. So D1, D2, and D1, D3. So you can see now one is constrained with 2 and one is constrained with 3 and so on and so forth. So D2 is with D1 and so on and so forth. Let's see. So D1 is sources, laser, sales, sheet, steer और ये domain है crosswords की जो हमने देखा था last time. The constraints are as follows जो क्या कहते हैं आपके पहले का third letter जो second का first letter होना चाहिए and so on and so forth and see how it works. So D1, D2. So let's start with D1, D2. This is this arc D1, D2. This arc. ठीक है. And you can see जनाब के D1, D2 में ऐसा नहीं हो रहा. D1 की अगर वैल्यू होल्सेस है देन D2 की वैल्यू जो है वो होल्सेस से स्टार्ट नहीं हो रही. क्या तो कुछ वैल्यूज हैं जो कि नहीं एग्जिस्ट कर रही. तो हम देखा जनाब के अगर मैं लेजर सेलेक्ट कर लेता हूँ तो थर्ड लेटर जो है वो फर्स्ट लेटर के कॉरस्पॉन्ड नहीं कर रहा है उस चीज को. अगर मैं सेल्स को स्टार्ट कर लेता हूँ then I cannot be the same value and then you can remove these values. Okay, you can keep on removing these and now you can see D1, D3. So now this you are making it consistent. Okay, you can see. Okay, now you can check in the reverse direction कि D2, D1 जो है वो क्या consistent हो रहा है यानी कि this constraint is क्या इस constraint में कौन सी चीज़ है जो satisfy नहीं हो रही. You will remove the values from these things ताकि वो values start हों जो कि सिर्फ काम कर रही हैं. And similarly for different fields. So again, I would recommend you to जनाब to go through this demonstration that shows you जनाब कि किस तरीके से चीजें जो हैं वो काम कर रही हैं. Okay. So after you are done, you will see जनाब के almost सारी values जो हैं वो आपको identify करें. So there is तमाम mostly जो values हैं खत्म हो चुकी हैं. You have only couple of variables remaining for different values. ठीक है जी. So again you can see जनाब के why this not does not work. So you can see जनाब के D1 में से दो वैल्यूज रह गई हैं. डी D2 में एक वैल्यू रह गई है. D3 में एक वैल्यू रह गई है. D4 में भी एक वैल्यू रह गई है. And you can see the almost the problem is solved without ever going to the byte tracking such algorithm. Okay, so you can use this thing for map clearing as well and you can drive it on your own कि जनाब map clearing कैसे इसको apply कर सकते हैं. ठीक है. So thank you for listening to this video. The last video we talked very briefly about the structure of the problem.